Deoxyribonucleic acid, commonly known as DNA, affects all of our lives in more ways than we could have ever thought possible. Take vaccines, for instance. They appear to be the hot topic of today, with the recent measles outbreak in California, and even just last year, the outbreak of mumps right here in central Ohio. And what about genetically modified organisms, or GMOs? I'm sure you've probably heard of them. They are used to create bigger crops and greater yields, while also creating pest-resistant crops and improving the nutritional value of these crops. And so whether you're for them or against them, it really doesn't matter, because most of our corn and grain products are produced that way right here in the Americas. And so you're probably wondering, what does the agricultural industry and the pharmaceutical industry have to do with one another? Similar to many aspects of crime scene investigations and disease therapy, the pharmaceutical and agricultural industry are used through DNA technology. Most of their applications are. And they rely on DNA technology to have their applications be successfully carried out. And so as a pre-medical student, DNA is often the center of my studies in biology and biochemistry. And so time and time again, it has been ingrained in every pre-medical student's head that DNA is the building block of all of life on Earth. It's a commonality between bacteria, plants, and animals. And so while I'm not going to get into the specifics of that, what I researched is, how did we get to know what we know today? How do we understand the structure of DNA and all of its impacts in the 21st century? And that journey to the discovery was surely not an easy one, nor was it a short one. And so today I will tell you about the discovery of the structure of DNA. Considered to be the single greatest biological discovery of the 20th century, we will explore how a joint effort from scientists across the globe contributed to this discovery, how Watson and Crick came to be known as the founding fathers of DNA, and lastly, we will take a look into an application of DNA technology with a detailed look into DNA fingerprinting. So let us first begin with the effort from scientists around the world that contributed to this contribution of the discovery of the structure of DNA. And so according to PBS.org, it was the American scientist Oswald Avery who proved that DNA contains the genetic material. And so in the late 1940s, this knowledge was widely accepted across the scientific community, but we still haven't the slightest idea how the molecule might look and even how it worked. And so at this point, we know that DNA contains 4 nitrogenous bases: adenine, thymine, guanine, and cytosine, but they haven't the slightest idea how the molecule was arranged in space. And so Nature journal states that Phoebus Levin became the first to discover the building block of DNA, also known as a nucleotide. And so a nucleotide is simply a phosphate, a sugar, and sugar being deoxyribose, and one of the 4 nitrogenous bases. But we still don't know how this molecule looks in space. And so soon, Erwin Chargaff made a major discovery. He discovered that the amount of adenine in a molecule of DNA was equal to the amount of thymine. Similarly, the amount of cytosine was equal to the amount of guanine. This discovery was major, and it was instrumental for Watson and Crick to discover the structure of DNA. And in the 1950s, the race to that discovery was on. So now that I explained how this discovery was made possible through various scientific efforts, I will explain how Watson and Crick came to be known as the founding fathers of DNA. And so James Watson was a young American research fellow, and graduate student Francis Crick were conducting research at Cambridge University. And so as most other scientists of the time, they were interested in DNA, but what was unique about this duo was that they were building physical 3D models to make their experiments, while every other scientist was in the laboratory extracting DNA and trying to view it under a microscope. They were doing physical 3D molecules using paper and tools and whatever they had at their disposal to determine the structure. And so every other scientist thought they were fools. They thought they were fools and that they would never figure out the structure. But Watson and Crick knew that what they were doing would allow them to narrow down their possibilities, and with this, eventually create an accurate picture. It was almost like a puzzle for them. And so Rosalind Franklin was working at King's College in London, and she took the experimental approach. She was looking at X-ray diffraction images of DNA. And so with these images of DNA, Franklin was able to determine that the phosphates were found on the outside of the molecule. And possibly, most important, she was able to determine that the molecule was helical. And so if you look at this picture, this allowed her to determine that the molecule was helical. And so unbeknownst to Franklin, one of her colleagues, Maurice Wilkins, showed this image of the X-ray diffraction to Watson and Crick. And so with this image, Watson and Crick were able to complete the puzzle. They determined that DNA was a 2-stranded molecule. each in a helix as Franklin had found, but they ran anti-parallel to one another. And so the backbone of the molecule was sugar and phosphate, and in the middle were the nitrogenous bases bonded together by hydrogen bonds. And so in 1962, Watson, Crick, and Wilkins were awarded the Nobel Prize for their discovery of the structure of DNA in medicine and physiology. And so at this point, Franklin had already passed away. And so according to NobelPrize.org, the award can only be given to 3 participants in one category, and they must be living. So some wonder if Franklin was still alive, would she have even been awarded this prize? Okay, so now that I explained how Watson and Crick came to be known as the founding fathers of DNA, I will explain how the discovery of the structure of DNA has led to many current and useful applications. I will focus on one application of DNA technology, DNA fingerprinting. Individuals have their own DNA, with the exception of identical twins, that is. And so DNA can be retrieved from hair, saliva, blood, amongst a variety of other things. So let us now take a look at a video clip from the discovery of the man who discovered DNA fingerprinting, Sir Alec Jeffreys.
That first murky, horrible-looking DNA fingerprint, that came out of the developing tank at 9 o'clock in the morning or nothing. And it was really, that was a magic moment. I think my first reaction was a bit of a murky mess, but then I stopped and went, we've got some fantastically variable patterns here. I don't think the term DNA fingerprinting had actually come into our mind then, but we saw the potential for individualization. So first reaction was, well, first of all, we've solved the rate of the problem here. We've got access to these really good genetic markers for mapping genes and chromosomes and so on, but we've got a method of biological identification. And so immediately started thinking of forensics. Could you use this in criminal investigations? Could DNA survive in crime scene samples? Could you match samples with suspects and so on? So those ideas came to mind very quickly. Then we spotted
Okay, great.
on that automated run.
And so that was Sir Alec Jeffreys, as I mentioned, the man who discovered DNA fingerprinting in 1984. And so within a year of the discovery, the first paternity case was solved. The first immigration case was solved. Within 2 years, in 1986, DNA fingerprinting was being routinely used at crime scene investigations. And so according to the Innocence Project, DNA has led to the exoneration of more than 300 wrongly convicted people. And so let me end by saying, the discovery of the structure of DNA is easily considered to be the single greatest biological work of the last 100 years, the last century. And so fitting together the pieces of this immensely complex puzzle spanned over the course of several decades, and it required scientists from across the globe to contribute to this effort. And only then, only now, do we understand what DNA truly is. And so while we can argue that all of the scientists involved have not been truly recognized for their work, what we cannot deny is that DNA has been instrumental in advancing many medical and scientific applications. And so now we know what the possibilities are, and truly they remain endless. Thank you.